Welcome to Season 3 of the Builders Podcast. I'm Matt Levenhagen. Here we share the journeys, strategies, and lessons that help entrepreneurs build what's next. Builders helping builders. Enjoy the show.
Hello, everybody, and welcome to another The Builders. Today, we are joined by Lee Rossey. Welcome to the show, Lee.
Well, thank you for having me.
So Lee is the CTO and co-founder of SimSpace. You want to just talk, tell us about what you do for about a minute or 2 minutes, what you guys do over there?
Yeah, the company itself. So we, and we'll perhaps get into a little bit of the background, but spent 15 years at a place called MIT Lincoln Laboratory developing technology. This is cyber ranges. A cyber range is a hyper-realistic environment to be able to develop and test technologies, train operators, and all that. So about 11 years ago, when we spun out, we established a company to do just that, mature and develop the cyber range that can be used by militaries, but also a lot of commercial companies, large banks, insurance, telco, to have a very realistic and rich environment where they can push teams to failure, push technologies to failure, do all the what ifs. So I like to think of it as like, just like in the military, you want to be able to train, test, push yourself in a realistic setup before you hit the real fight. So how do you mature and develop those skills and prove out the technology before somebody really, quote unquote, punches you in the face to do that? So build that muscle memory. But fundamentally, the range is the environment within which I'll say enterprises and users can use to be able to, push technology, figure out which technology is appropriate for them, and the teams as well to be able to run it. And we'll probably talk about this a little bit later. In the age of AI, what does that actually mean in terms of enterprises buying all of these new AI cybersecurity solutions, transforming organizations, and they have the operators, the humans, side by side with AI technologies, they're getting against a rapidly accelerating threat. You hear about these AI offensive agentic solutions. So it's exciting times. Let me just say that. It's exciting on all kinds of fronts. And now...
Exciting if you like the challenge. Yes. Yeah.
There's always this wave of technology, whether you're going from mainframes to client server to mobile, OT, and we're in the age of AI, and it is disruptive and it is exciting.
Yeah. Awesome. Well, that's a great foundation. We know who you are, what you're doing over there. So the next thing let's talk a little bit about kind of how you got into this, kind of your own story of how you landed at MIT and all that cool stuff. I mean, MIT is so cool. Like, if you could just say I was at MIT doing anything, you're the coolest dude in the world, man.
Okay. Sometimes
I would love to be able to say I went to MIT.
No, but let me just say the interesting part was, let me qualify. So picture being a young engineer coming out of school, twirling around with technology. It wasn't called cyber at the time. It was information operations, information assurance, all the old thing. But at the end of the day, it's computer security and information security. So I joined the lab in 2000, so about 25 years ago. And it was actually kind of cool. So picture being a young engineer at heart and having access and the opportunity to work on national security problems, which is what the lab does. The lab focuses, so MIT Lincoln Lab is the portion of MIT focused on applying advanced technology for critical national security problems. So in that context is, okay, great. So there's a technology foundation. We want to solve hard problems, but let's apply them to national security needs. And national security is from the lab, air defense, missile defense, space control, a lot of traditional radar-based environments. I'll get to cyber in a second, where the lab was basically set up originally in 1951 to develop air defense systems against Russian bombers trying to drop nukes on us. So that's how the lab started.
Yeah.
It evolved into all kinds of stuff to do that. But when I started there, it's like, okay, how do we actually think about cybersecurity? I'm using cybersecurity now, it wasn't called that at the time. Cybersecurity in terms of the advances, the threat, the defenses, what do we do about it? Yes, like we all recognize, every one of the traditional environments, whether you are a bank, a manufacturing, a power company, yes, there is that machine element or bank, but now there's a security implication from a computer side, a network side. And so how do we measure? How do we create data sets? How do we evaluate it? How do we advance technologies in that concept to do that? So early on, it was shops like DARPA, one of these research agencies developing new technologies. From the DARPAs of the world, companies emerge. But the lab always takes an approach of technical prowess. I need to understand the problem. I need to understand where the technology is going in general. I need to be able to also evaluate and measure. I don't want to just pontificate a problem. By doing, you learn. So there's a strong element of evaluation, testing, measurements, and it doesn't matter if it's an airplane, a radar, or cyber. There's that DNA ingrained in there. So at least when I was there, it's all about creating very realistic and rich environments to provide
Mm.
the means to create the data sets and the evaluations and the foundation to be able to develop and test all kinds of new cybersecurity solutions back 20 some years ago, 25 years ago, that became the foundation for what we're doing as a company. So in other words, helping out the Department of Defense, helping out the intelligence communities, created technologies and capabilities at the lab, but then deployed and pushed out into every one of the major, let me say, government labs developing cyber stuff. So you get access to the problems, you understand what everybody's doing. Great. Um, and we got to a point in 2015 where technology mature, teams are mature. We've run a few tests, we gelled, and so then we spun out as a company. So the company is basically an extension of a lot of the great work that I think we were doing at the lab in terms of pushing technology, developing these very realistic environments, seeing what was quote unquote coming because we were helping to develop a lot of these tools, and recognizing that it was going to hit the commercial side. So the same threats that, example, hit the banks are hitting. We're here in Boston, are hitting the local power companies in Boston and banks in Boston. And even though they may not have had the defenses, the technology, and the teams, you can see that wave is coming, and
Yeah.
effectively it has.
Did you spin it off as a separate company or like, or is it still associated somehow?
No, no, no. So a bunch of us came out of MIT Lincoln Laboratory. We spun
Yeah.
out in terms of some of the people. So the foundation was tech guys from MIT Lincoln Lab. The other co-founder, Hutch, he's an F-15 fighter pilot. He was assigned to Cyber Command. So this is during the early days when Cyber Command was getting established, getting budget. Hutch always jokes about they assigned him to Cyber Command to be able to do some exercise and do some training. All right, we now have 6,000 plus operators, and he goes up to the general. He's like, all right, cool. Do we know what the T structure looks like? No. Do we know what the tools look like? No. Do we know do you have an environment to operate? No. It's like, all right, got it. So again, it's
Great.
the early days. Again, at this point now, it's a much more mature and developed force.
Yeah.
But in the early days, it was just establishing the command, the structure, the teams, and now it's a matter of figuring out what's the environment to be able to work in. So there was that operational element tied
Yeah.
together with the cyber and the technology. So picture as an F-15 fighter pilot, you go out to the desert in Vegas, you practice things like Top Gun. How do I rehearse? How do I practice? How do I go up against the model
Yeah.
adversary? And that's where you build that experience. So taking those Top Gun-like experiences and now applying it to cyber was the approach. And that's how we
Right.
started. But that extended on into all kinds of commercial.
Yeah. Well, so we'll get into that in a minute. I'm curious, like, why you yourself, what attracted you to this? Like, how did you, like, was there some event in your life or like, cybersecurity or whatever it was called back then?
No, just engineer doing
You
computers
just fell into
and all that.
engineering. Okay.
Yeah,
Yeah.
I'm an engineer. I'm an engineering background. So
Okay.
engineer, come in there, cool problems, interesting tech. I joke about it's about moving the needle as in having an
Mm,
impact. So the lab did that and it was exciting. And I think we really did
yeah.
move the needle in terms of having an impact for what we were doing in a number of
Yeah.
areas. So
Yeah. I'm
I
just
would
always
say it was
curious,
more.
origin story. Like, why is this guy I'm talking to doing the things he's doing? Like, was there some kind of, you were bit by a spider or something and you turned into like, cyber,
No,
cyber
nothing that
Spidey or
exciting. Honestly, sometimes you look for interesting problems and people doing that, and that's how
yeah.
how we
Okay.
ended up over there.
Cool. No, it sounds like you just kind of were there. The opportunity arose and you jumped on it because you thought it
Yeah.
was
So
cool.
I
Yeah.
think like probably a lot of young engineers or others, you go to places that are doing and working on exciting problems, whether it's a commercial company, Google some of the research labs, or could be some other thing. you develop a lot of experience, you understand how it goes, and eventually the question becomes, do I want to actually spin out and actually grow this to
Yeah.
something myself? And so I think that came during the later parts, but the early parts is about building and working on interesting problems. And then
Yeah.
eventually it's like, how can I have a broader impact and spin out? And I think that's not an atypical story. You want to have some experience and some domain knowledge
Mhm.
about the problem. And then it's like, all right, I think we can help broader and there's a commercial appeal. But it was
Yeah.
the attraction towards hard, interesting problems that have an impact.
Can you talk about any stories from the early days that kind of stand out as something really, really interesting that you guys solved or you
Yeah, I
uh,
think in a general sense, the challenge is a lot of the stuff that the lab was doing are sensitive
yeah, of course.
because they are national security problems. But at a high level, I think the early days was it was called intrusion detection systems. So DARPA had a series of these programs trying to figure out how do I create, they called it intrusion detection systems. Now the fancier name is EDRs or endpoint detection and response and all that. But how do I develop, how do I select a series of companies that are going to develop a lot of these new novel ways of finding attackers in a network? And we started off by creating these synthetic data sets. These synthetic data sets were the means by which how can technology developers create new technologies and have a labeled data set, a labeled set of data to be able to run it. Um, when we did that, that was the first time in the field that any researcher and any company had what they called a labeled ground truth data set that they could work with. So it helped shape a lot of the foundation for many of the early technology companies working that problem because they simply did not have access to the data or the problem to be able to actually develop and test what they were doing.
Oh, so
So
they
that
had
data
nothing to
set
test with. Okay. Yeah.
was widely used throughout the community to be able to run it. From that, many government agents said, "Oh, that's cool, but I don't want some generic version. I want something that matches my problem." So there
Mm,
started becoming a version of that that can be applied into the various setups. But without getting into too many details, I think the interesting part was cool. So we're doing the cyber, we're trying to figure out how to deal with computer networks and security there, which is a challenge. But from a lab standpoint, is what's the impact that cybersecurity can have on, I'll say, national security problems. So air defense and space
mm.
control and broadly speaking, weapons. Are the things that we depend on survivable? By survival, I mean when you expect an airplane to take off from the runway, it does that. When you expect a radar to see incoming stuff, it does it. And so we started marrying up a lot of the traditional systems, air defense, space control, all that kind of stuff, with the cyber to try and say, all right, if I was an adversary, could I get in there? Could I do something? Could I disrupt the operation? Could I have that effect? And part of being at the lab, we had access to a lot of the real systems, which is great. So then you can actually demonstrate. Sometimes you can do PowerPoints and brief somebody all day long, but
Yeah.
it's not until you see it for reals. It's like, okay, the light bulb goes off. It's like, okay, now this is, I get what you're saying. It's not just shooting
Yeah.
an email at my radar. It's, okay, you can really disrupt it and others, or you can use cyber to blow up some power plant by making it go a little bit out of control. Now, examples in the news that are historic is the like Stuxnet, which is a virus that was developed to be able to take out some nuclear facility in the towns for enrichment. But those are examples. That's not. I'm not using. So that's just an example of something people have done, which showed how cyber can have an effect on traditional environments. So there's a lot of examples like that that was really excited to be able to actually move. And once you start understanding that, then the question is, if it's going to hit traditional military and national security things, it's going to hit the banks, it's going to hit
Sure.
the cities, it's going to hit all the other. And so that's what we want to be able to say is like, all right, how do we help out a broader set for the wave of what's coming? And by the way,
Right.
we're
Right.
seeing that now. We're seeing that wave of what's coming.
Right. So so there's such a thing. So I'm trying to envision exactly how you guys test now. Like I'm thinking about that. You have I know companies and stuff will hire other companies or people that maybe have, I don't know if they're called good hackers or ethical hackers or something
Yeah.
like that, where they got these guys that come in, they hire them to try to break a system. Is
Yep.
that kind of what we're doing here? You're trying to, or you're automating that process?
It's more the later. I think these red teams, ethical hackers, red teams, you pretend to be an adversary. You've been skilled up in terms of knowing how to break into networks. Awesome. And let me paint the picture, and then I'll tell you the challenge and the solution. So a large bank will say, hey, I want to find out if I'm weak or not weak against an adversary by hiring a pen tester, a red teamer, somebody that looks like an adversary whose job it is to kind of get into my network. So as they do that, they can figure out, okay, problem A, B, C, and D. Got it. This is how you got in. Now let me show it up. It's effectively an independent test of the security controls of the teams that somebody has had, which is
Mm.
super valuable. It's super valuable to be able to have, when you're the designer and the build of your solution, you don't always think of it from the other side. So you want to
Right.
have somebody else try and break in and do that. And that applies to all kinds of domains. So that is a manual process. That is a manual time consuming process where you have to hire a team. They have to kind of go in with minimal knowledge, ideally, and figure out how to get in and have some effect. Steal data, take down systems, you name it. There's two challenges. Doing that in a live production network, if you're a big bank and have a lot of ATMs out there with people trying to pull money, or you're a hospital trying to care to patients, or you are
Right.
a manufacturing plant trying to build cars, you don't exactly want that red team to really show you that you've taken that system down and offline. It's expensive.
Right. Right. True. Yes.
It's very painful. And so there's always guardrails put on what you can really do in production, because show me that you can have an effect, but don't do anything that's going to actually mess up with
Well,
my day-to-day operations.
right. It's not unlike web development. I have a web design agency
Yeah.
and development where we always have, we can do some stuff in production,
Yeah.
but especially if it's an e-commerce store or something like that, where there's sales coming in, there's all this stuff happening. But a lot of times you want to spin that off into a staging environment or something where you can safely do this testing.
Honestly, it's exactly that. It's literally
Yeah.
that. So there's the production, cool, live, running, making money, doing what it's doing. But how do you have the pre-production, the staging that you're going to be using dev test environment? How do I actually run all kinds of tests against it? How do I make sure that it's scalable and robust and that it's somewhat robust against the attacks? That's literally what we're doing. So because you can't do those real tests in production, let me get a version of that production network, a like version. Some people call it a digital twin, but that has a specific meaning. So think of it as a cousin or a like. It has to be representative to what that company has in terms of the architecture, the security tools, the controls. All right, cool. I have a little mini version of that production network. Great. Now I can put the security tools in there. Now I'm going to put the controls in there. And yes, I can put the red teamers and let them go wild and kind of do what they want to do. But you know what? Sometimes it's not just technology. It is the tech is going to do the best that it can to prevent and harden and block. But once an adversary gets in, it's all about those operators. There's humans that are going to detect and respond. So how do we give the operators, the ones that are hunting, investigating, analyzing, a chance to reduce the time to do that? So to your point, we're going to stand up a representative replica of that environment, put the tech in there to be able to poke it as much as possible, and then help the teams detect and respond as fast as you can. So yes, you can put red teamers in there and let them go wild, but this is where we have automated attack scenarios, automated red teamers that are going to go through and say, hey, this is what a typical attack coming out of, they call them APTs, advanced persistent threats. Here's an example of what the Russians, the Chinese, the North Koreans, the whoever's doing. Let me rerun these full attack scenarios through this environment and now measure the effectiveness of my technical controls and my team responses to do that. So your analogy there to application development with all the dev test and staging is 100% that. But now take that as a version of a production network. Now, where's the tech come into play? With infinite time and money and people, you can recreate everything, but you don't want to spend years and thousands of man hours creating a version of the network. So the key here is automation. It has to be fast to be able to automate it and build it all out so that it doesn't take 6 months and 1,000 people to create that version, because you're never going to spend the time on it. So you want a model, but you want to be able to create that model high fidelity and representative, but fast.
Yeah, and you got to the system has to always be updating too, right? I mean, when there's changes on the main production or whatever. So there has to be some kind of process there as well.
It doesn't have to be on a daily basis, but I would say that on a yearly basis, if you will, technology evolves. What was important for what a network looked like 10 years ago, client server setups, firewalls, domain controllers, exchange servers, super appropriate. But now, look at all the public cloud services, AWS, Azure, you name it, GCP. There's a whole new stack and set of services. So as the enterprise landscape evolves, the environment evolves because the attackers go after wherever the data is. And if the data is in the
Yeah.
cloud, you got to be able to model that, set up, and defend it. And the other element is I think of three environments that need to be modeled. There's these traditional on-prem environments, the ones that have been built out over the last 50, 60 years. There's the
Mm.
cloud element that is all over the place and it's important. And then there's this operational technology, the industrial control systems that a lot of places have. So if you're into manufacturing and power generation and oil and gas, that has a bunch of pumps and valves and relays and things that move and all that. That's part of the surface area. That's part of the
Yeah.
attack. So how do you defend against attackers trying to disrupt gas generation and distribution? Colonial Pipeline was one of those attacks that hit the U.S. 4 or 5 years ago, more or less, and go through that. So the
Interesting.
attacks,
Yeah.
yeah, 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 and I think those are important areas that we want to be able to model and help companies out figure that out.
And so do you have your kind of like proprietary like software or whatever that helps you create these automated systems, or
Yeah.
like you have a lot to, does it like crawl the system like this is what we need? Whatever, or somebody, how does that work?
Yeah, I'll put it into two categories. One of them is, can we create sector representative models? Something that quote unquote off the shelf looks like a power company or looks like a hospital or
Mhm.
looks like a business network or financial. Cool. I got the basic blueprint, the skeleton of what that is, and now let me add in the security tools. But it's not a one-to-one match. So that's
Mm.
that's category one. Let me get off the ground quickly to prove some things out, do some POVs, that's going. And then the second one is, how do I get data from a production network? The IP addresses, the security details, all that. That's more sensitive, but that can be done in a semi-automated way, but with the right trust from that company that we can protect that data to be able to actually do that.
Yeah. Wow. And so let's talk a little bit about AI, like how
Yeah.
that especially in the last couple years, that has probably made you pause and assess, reassess, think about things that you never had to think about before.
Um, yes and no. So you have to go into the assumption that technology is always going to evolve. It's always going
Yeah.
to be changing. No matter what you built, it's going to change a couple of years from now. So this is the next evolution. The rate at which it's changing is impressive, and that
Mm.
that part is really interesting. So there is a technology aspect of AI that is, I'll just say in cybersecurity, one of the goals is how does it automate a lot of the job of the traditional SOC tier one, tier two analysts, the people that are doing the front line, analyzing, triaging, looking through. It's not perfect yet, but there's an element of those jobs are going to get much more automated. So then how does that technology fit it? Not 100%. I'm not saying that it's replacing all humans. What I am
Mm.
saying is that the operators are there are going to be enabled by AI to be a lot more effective. They can analyze much more data quickly, be able to figure out, I call it a signal to noise problem. The signal is the attacks in the middle of all of these mounds of alerts. Picture a very large enterprise that's just
Yeah.
generating millions and millions of alerts a day. All right. Picking out the attacker in the middle of all of that noise, AI is absolutely helping with that. So
Mm.
now it's a matter of cool. So I can sift through the noise faster. Great. But the adversaries are doing the exact same thing. They're
I
using
was gonna say
AI
there's
to
a balance. I mean, they're doing, the adversary is like, they're using AI now to, create even more noise or whatever you want to call it.
well,
And
they're
then you
getting
guys
more
are sifting for more.
sophisticated. The spear
Yeah.
phishing emails, the emails that are used to kind of get into a network, much more
Yeah.
realistic.
Yeah.
There's a social aspect of it where they're impersonating users, they're impersonating people to make it look like it's a legitimate guy. That's one aspect. There's AI being used to accelerate the kill chain. The kill chain being here, the steps required to be able to, from the outside, do the reconnaissance, do the understanding of what the vulnerabilities are, come up with an exploit, target and pivot. So these things that took, I'll just say, months to years to kind of work through, or weeks and beyond, are
Mhm.
now getting dropped down into, let's just say, hours to days. So the
Yeah.
rate at which the attacks are being able to identify, discover, get in, find exploits is impressive. So the good news is AI is absolutely helping the defenders, but AI is also helping the adversaries. And what
Yeah.
this really means is that the loop between when an attack starts to when you respond and kind of go through is getting a lot faster. And so that's what I mean by it's an exciting time. So as things accelerate, now the question is, how do we help vet the technology, the defensive tools? How do we help the teams cope with this, with that acceleration? How do we help enterprises think through that transformation of what are the processes, the tools, the business? How do I change how I do business when I'm actually leveraging some of these tools? And you can argue that I'm not going to change. The problem is the adversary has a vote and they're still going to be poking at
Yeah.
you. And if you don't, so there's this balance between I need to be proactive. I need to leverage technology, but I need to make sure I'm safe. I trust it before I actually completely let it go over a lot of the stuff. So that's what I mean. It's exciting times. There will be a lot of changes. And we're in that process now of helping people out. We are helping out the people developing the solutions. I jokingly call it as the builders, the ones that are creating technology. How do you have clean, labeled, high fidelity data sets? How do you train these agents to understand the context for an enterprise? If you're going to replace a human, quote unquote, how do you give them that context for what's important to your enterprise so that these agents, agentic, are trained on the type of data that's represented to your organization, not the foundational models, but train those agents to have that context for you. Awesome. Now,
Right.
now we're a little bit more tuned to the environment. But then the other one is, do I know why it's making the decisions that it's making? Do I trust the output of those decisions? Is that model co-optable or that agent co-opted? No, can I attack that agent? Can an adversary drift it or give it some kind of prompts and injection to be able to get some data out of it that it wasn't supposed?
Right.
So any great new technology always has, it's a double-edged sword.
Yeah.
Always
I
has
mean,
the
that's even
advantages.
because now you're up against just the creativity of the system, like to be able to prompt
Yeah.
you to get around. I mean, how do you even model or like test for that? That's crazy.
To some degree, it's a black box, but the more complicated the system becomes, the more opportunities an adversary has to take advantage of some of that complexity to
Mm.
to do that. So I think that's where, from a SimSpace perspective, we're using this term AI proving grounds. So we were supporting a lot of training of teams and testing of the tools, but from a proving ground standpoint, is technology is what it is. We got to model the landscape. How do we now start adding in the, I'll call it the AI agentic solutions? New blue security tools, are they effective? Are they safe? Are they trustworthy? Great. How do they work with operators? How do we close that loop where they're looking at the governance, the controls, the risk, the speeding up the operations? How do we add in automated human attacks to be able to go after it? So this need to have rich environments that are representative of your organization to accelerate and vet and prove out actually is really important to us to do that. So we think about it as AI and humans side by side working together to be able to actually go through. If it's humans without AI, honestly, they're probably not going to be effective to do it.
Yeah.
It's kind of like I'm on a rant here, but it's almost like coders. A coders with AI is almost the new norm. That's gonna it's gonna make good coders great. If you're just gonna be just straight coding without leveraging the technology, you're gonna have a challenge.
Well, they say like it, and it's true. And I code, so for me, it's I don't without my Claude code or whatever
Yeah.
model I'm using at the moment. In my cursor editor, like I don't even know what I would feel like if I didn't have that with me at this point. It's doing a lot of the coding for me and everything. But I think it's what they say. It's the people that aren't like all the jobs aren't going to be replaced
No.
by AI. It can be the jobs that the people that aren't using AI are the ones that can be replaced. You have to be just stay up to speed in anything, even what you're doing there. And it gives you capabilities and stuff that you just got to learn to work with it and what that
I think the
relationship is.
coding I think the coding is a good example. If you're a good coder, AI is going to make you better. If you have no idea
Mhm.
how to code, all right, it's going to do something, but who knows? How do you trust it? How do
Right.
you know what it's doing? And blah, blah, blah. The same is true for cybersecurity. You have to have a foundation in understanding what security is and IP addresses and networks and what does good look like. And then AI accelerates and
Yeah.
empowers and makes you more effective. I don't see us at a point where there's no human in the loop at any point in that stack. Because again, even if you automate a lot of these things, governance, controls, safety, there's still
Yeah,
things that
there's
you
a
need to be
lot of
thinking through.
things at play. I mean, like
Yeah,
I don't, and maybe it will someday. Maybe it'll just become us. We'll do everything. But as I work with it, I'm constantly catching things, and I have to guide it and
yeah.
kind of have the plan for it to do its thing. but there's a lot of times I'm like, or I'll have another AI check it, like, and it'll find things, but they're not perfect.
Yeah.
And I'll be like, why did you just delete all that stuff? I didn't ask you to delete any of that. Or, is there a better way to do this? Or why, but you have to have that seasoned, web developer or
Yeah.
programmer or coder that does understand the systems. The AI is just there. They're kind of like your junior helper.
Yeah, and every year it's getting more powerful. Every year it's getting
Yeah.
better, less hallucinations, less blah blah blah, all that kind of stuff. So it is getting more effective every year. And again, the rate of change is impressive. It is really
Yeah.
cool to see. Again, whether it's cyber or autonomous vehicles or robotics, I love seeing the Waymos running around and
Yeah, it's
doing all
wild.
that stuff.
It's wild. It's wild times.
Really
It's incredible times. So, do you see anything new on the horizon coming that none the average person isn't even prepared or seeing?
Well, in cybersecurity, which is our domain,
Yeah.
the immediate thing there is AI is the big one. AI is the big one. It is going to be changing things. I think there's a lot of technology vendors that are all racing towards coming up with some solutions. You can
Yeah.
just look at the news. There's lots of money being thrown into AI for cybersecurity. Whether you're an established company, a lot of the big hyperscalers, the big names that you see, they're all investing in AI to accelerate, to enhance their products. But there's a whole new generation of companies that are going to be coming up that did not exist 3-4 years ago. So
Mm.
there's always going to be this set of established players that are going to transform and evolve. Great. Or they're going to die, to be honest. And there's a new set of players. Like, even if you look at the cloud, think of all the cloud companies. Microsoft came out with Azure and they created all these things. But there's a whole set of companies that did not exist years ago that just jumped into it. I think the
Sure.
same is going to be true for AI. There's always an element in these early days of hype versus reality. So, what does the website say versus what actually works in practice? That goes back down into measurement, testing. Let me demystify. Let me understand the operating envelope. So I think we are in the early days of AI adoption and all that, which is exciting. So again, there's going to be a
Mm.
bunch of companies. Some are going to fail. Some are going to be awesome. In the next year, I think right now a lot of enterprises are running pilots to try out, hey, this company looks awesome. This one looks great. They're trying to figure out where AI applies to them. What parts can I automate or leverage it? There's these trials, but nobody that I've seen has rolled it out into production and replaced everything yet. So I
Right.
think in a coming year, so this is the 2026, broadly speaking, is going to be the year of the vendors coming up with more and more robust solutions, handling more corner cases. I make the analogy where it may work in a lab. Does it work in a complex, real production network? Okay,
Yeah.
there's going to be some of that. 2027 is going to be more of adoption by large enterprises getting into all that kind of stuff to do that. So I think for the next few years, it's going to be this maturation and adoption and transformation of a lot of these new capabilities into enterprise. And when I think enterprises, it's banks, it's militaries, it's governments, it's manufacturing, and all that.
Yeah.
There's a separate element of AI applied to manufacturing, smart robotics, all that kind of stuff that eventually is going to have an angle on that one as well. But I think the next few years are going to be very fast and exciting to see what happens. And again, I think the set of companies that are dominant today are probably not going to be the same list of names in 3 years from now. Who they are? Wow. We're on that
That's
ride.
be interesting. Let me ask this question. So, there's danger involved
Yeah.
with AI and everything happening. Like,
Yeah.
and I don't want to be the guy that's going to ask you, what percentage do you think, that we're going to just all like just perish from AI? It's going to kill us all. Are we good? You think cybersecurity is in a good place where it's keeping up or there's any threshold do you see in the future where it's like, we're not going to be able to
Call me old and
survive?
grumbly. I've been playing in this space for 25 plus years. It's always the same story.
It's
Attacks
always
are
the same.
moving forward. The defenses suck. They were really not good. So the attacker's having a field day. It's always this cat and mouse. The cat and
Yeah.
mouse is always evolving. Um, Is there an impact? Of course, there's some. Are we all going to die? Very unlikely. I don't see us with a point where the
Yeah.
AI is going to just kill us all off, a la Terminator style. There's 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 going to be an evolution, absolutely. I mean,
Yeah.
we were not even talking about cyber 20 years ago, but it was always there.
Right.
It was just not something that was coming through. It's more prominent in day to day and moving. It's just something that enterprises to be successful and survive need to adopt it, leverage cybersecurity
Mhm.
in general. Adopt it,
Yeah.
leverage it because people are going after it. I don't think it's going to it'll change the roles of the humans, the operators, and the application technology. It's not fundamentally going to shift the numbers in terms of the
Mm,
people and are doing. I think what they do is going to be different. The numbers are not going to fundamentally change in terms of the need for them. In other words, I still think there's going to be a set of humans that are going to be there to be able to run these businesses,
right.
operate through, and go through. We can talk on the margins about maybe there's a smaller growth, less, but it's. I make my analogy when ATMs were introduced and the bank tellers were all worried about losing their jobs. It created
Right.
a
Right.
whole different set of jobs, but the tellers themselves were gone. But the
Yeah.
need for the humans changed, and I think there's similar analogies that are going to play out.
So as far as SimSpace, what's kind of your market? Who do you serve mostly?
Currently, large enterprises, very large
Just large enterprises,
enterprises, Fortune 1000.
banks, and
Yeah, militaries throughout the world. So we are the established standard for any large military. How do I train my operators in team-based? How do I do mission rehearsal, which is practice for an event? How do I select the right new technologies? The militaries are going through the same transformation. I have some stuff right now. How do I figure out how AI plays in terms of what I do? So large governments and militaries, large multinationals and enterprises to be able to run to do that. Mainly because there is a certain amount of those are the organizations that are investing in the technologies,
mm,
investing in the people and the maturity to do that. We're more in that segment, and it is worldwide. We were primarily the U.S. for a while, and now we are working with a lot of shops in, say, Japan, Asia,
interesting.
Middle East, Europe, to do that. But I would say large mature organizations are a good fit for SimSpace.
Well, thank goodness you exist because we need you. we need to. We
We
need.
think so. But honestly, now it's actually more important to have something like us now than it was a year ago because
Yeah.
of the changes, of the transformations, of the impact that it's going to have on the tech and the people, and really helping figure out what is the right solution, what is the right tech, how do I use it effectively, and that's what I mean by it is exciting times.
Yeah. So if somebody wants to learn more about what you guys are doing, where do they go? And do you hang out anywhere on the World Wide Web? If somebody wanted to reach out to you and
Uh,
ask you a question?
First part is the website. Simspace.com. Go to the website. Most of the details are all there and go through. It has a bunch of contact info how to reach it. Myself, LinkedIn, website, other stuff like that. Where do I hang out? I live in Boston right now, but I do travel a decent amount.
Awesome. Sounds good. All right. Well, thanks, Lee. It's been a pleasure. It's really interesting stuff you guys are doing. Again, we're thankful you exist. Till next
Well,
time.
thank you for hosting us and get a chance. Great discussion. Loved it.
Thanks for tuning in to this episode of the Builders Podcast. One more quick note about our sponsors. At Unified Web Design, we're passionate about doing better together, partnering with agencies and businesses to deliver exceptional web design, development, and ongoing support. And UnifiedLabs.ai is where we explore smart, practical ways to integrate AI directly into your website and e-commerce flows. From intelligent chatbots to marketing automation to back-end reporting, all with a strong focus on user experience and making your systems work smarter. If you haven't already, subscribe or follow to stay updated on future episodes. And if you enjoyed today's conversation, sharing it with someone who might benefit helps us grow this amazing community. Until next time, keep building smarter, bolder, and with purpose.